Hi, welcome back to the lecture series on IC fabrication. In this session 2, we will talk about the sand to ingot fabrication process. In the last session, we talked about the introduction to IC fabrication. We look inside clean room, major fabrication step, and state of the art technology. Now we will talk about how basically we will fabricate ingot from sand. This is one site on YouTube. You can see a complete video how we can fabricate silicon chip from sand. There are a number of various other sites also. I felt this is example very good. You can refer if you want to see the actual scenario of fabrication plant. Now let us proceed with the points. Crystal growth process. How basically we form ingot from sand. So in the last session I showed you this slide that this is the sand and this is purified form of sand known as quartzite. This is purified silicon, that means known as electronic grade silicon, and this is your silicon ingot. Okay, so these are the major steps that what basically happen. We will start from here and we will achieve here. So let's start. First of all, let us take sand and some raw material, and what basically we do, first of all we purify the sand and we will obtain this quartzite, that is purified form of sand. Then what we will do is that we will take a furnace. Okay, and inside the furnace we will put all these materials, all the raw materials like quartzite that we have already discussed, the purified form of sand, coal, coke, wood chips, etc., any other raw material which is abundant in nature and which contains Si. Okay, so that when we burn all these materials into this furnace, what happens at a very high temperature, more than 1600 or 1780 degrees centigrade, what happens, a number of chemical reactions take place, and finally silicon is removed from all other materials and we get it out from this discharge pipe. Okay, and the major chemical reaction we can say SiO plus CO form SiO2, then SiO plus 2C form SiO plus CO, SiO2 plus O form SiO plus CO, and finally SiO plus SiO2 forms Si plus SiO and CO, where SiO and CO and H2O comes out and in gaseous or liquid form, and Si comes out from this path which is known as MgS. This silicon material which we take out from the furnace is known as metallurgical grade silicon. The meaning of MgS is basically that it is pure form of silicon but not highly pure. Near about 95% it may be pure, but it is not 99.99 or 100% pure. Okay, so this metallurgical grade silicon may be used for various other industrial purposes where silicon is required but not in highly purified form. But for IC fabrication, this is not suitable. So we have to obtain EGS from MGS. That means EGS, as I already told you in the last session, is purified form of silicon, that is 99.9999% form, pure form of silicon. So what are the further steps? The first step was, it is mentioned here, produce metallurgical grade silicon by heating silica with carbon. Okay, inside the furnace. Finally, SiC plus SiO2 form Si, and SiO and CO gases comes out. Okay, now this Si liquid form, okay, when taken out from the furnace, becomes solid. Okay, now purified MgS, metallurgical grade silicon, through a chemical reaction to produce a silicon bearing gas of trichlorosilane. So what is the next step? That we first purify MgS by reacting Si with HCl gas, forming HCl3 gas. Now the SiHCl3 gas then combines with hydrogen gas to form Si and HCl gas, again taken out. Okay, so this reaction takes place, forms SGS or EGS, that is electronic grade silicon, and takes place inside a chamber. This process is known as chemical vapor deposition process. Let's have a look on this diagram at what basically this process is. In this process, this is, let us say this is a chamber, okay, and let us say this is a polycrystalline rod. What happens? Gases comes from this side and gases went out from this side, okay, and all the silicon material deposited over this, okay, and other gases will emerge out from the chamber. So this is the simplified uh, detail that how basically uh, it is get condensed and deposited onto the polycrystalline silicon material, and we take those silicon material out from this chamber. This is in this form as shown here, okay, and this purified silicon is then further processed into a furnace to form this silicon ingot. Now there is one more video, if you like you can watch it on the YouTube also, that will give you some more detailed information how basically this ingot and is formed, okay. So let us proceed further, that now we have finally achieved, we have received this electronic gate silicon which is 99.99% pure, and now we want to obtain this silicon ingot, okay, for fabrication purpose. Purified silicon is obtained. Now the next step is to obtain ingot. How basically we do that? The widely known methods are Joukowski method or float zone method. Okay, we are discussing. I am going to present you some detail about the Joukowski method. In Joukowski crystal growth apparatus, also called as puller, as this is the text which I have taken from one standard book SMG. As mentioned in this book, the one picture weighs 17,600 kilogram and 6.5 meter tall machine is there. And this puller can configure to hold a melt charge of 60 kg of silicon at once, which can be transformed into a crystal of 100 millimeter diameter and 3 meter length. 3 meter length ingot we form basically. Okay, it has four main parts, and let's see those parts with the help of this diagram. So this is basically Joe Kralaski puller machine. Okay, we see the major parts. These are mentioned in this diagram. Let us see this in another diagram here. Here, if you see just in the middle, here this is mentioned as seed crystal, onto which we will take out all the pure form purified silicon to form a large cylindrical ingot structure. Okay, how basically this happens? Let us see another diagram. With the help of this, it will be clear to you. Actually, here what happens that here we have a big furnace, and we melt all the electronic gate silicon inside this, and then what we do, we take the seed crystal onto inside this, and then we rotate it, and at the same time we rotate the furnace into the opposite direction. So what happens? All the dust particles remaining will go outside, and at the center, the seed crystal, when taken out again back from the furnace, it takes some charge with it, some melted material with it, and when it comes out from the furnace, it solidifies. It solidifies, and hence, when we continue this operation, we pull it, we get the purified form of silicon out of this in a cylindrical form, and any dust, anything else remaining will be washed out. Okay, so let us understand it with the help of one video. You can watch this video, you will get a clear pictorial view of the same. Okay, uh, let us take one picture to understand it. Here, this is what crucible support. So this crucible support from the bottom side, rotates the crucible in one direction. Okay, and on the upper side there is seed and single crystal silicon. So from the puller, basically this seed crystal is coming inside this furnace, and when this furnace is rotating in one direction, let us say clockwise direction, then this puller rotates the anti-clockwise direction. Okay, so this is how basically the operation takes place. And when we take out the puller, the seed crystal, here you can see that this melted portion comes with it and solidify when it comes out of the furnace. Okay, so you can see this picture and you can understand this point what I want to explain. That silicon ingot grown by scissor head method coming out of the furnace inside the puller mechanism. Okay, so finally it comes something like in this shape out from the furnace. Another method widely known accepted is float zone method. We are not discussing that right now. So we can say that we have discussed that how basically sand to ingot can be formed in this present session. In the next session, I will talk about that how basically wafers can be formed from the ingot. It seems that it is very much simple process. We cut it in different pieces, we will get circular disc like this, and we can say that we have obtained wafer. We do something like that, but the process is a little bit lengthy and some more operations are required. So we will discuss those operations in our next session. Okay, till then, thank you.